I'm Mariam Issa, and today we're going to be demonstrating an experiment that distinguishes aromatic nitro compounds by reacting them with sodium hydroxide and observing the resulting colors. This is a useful test in organic chemistry to help identify different nitro groups based on visual indicators. In this experiment, we're going to need 10% and 20% sodium hydroxide solution, ethanol, acetone, some control compounds like nitrobenzene and dinitrobenzene, and finally our unknown so we could test it out. We're going to be using as well some beakers, about 6 test tubes, a graduated cylinder, a plastic pipette, a spatula, and a watch glass. Sodium hydroxide should be handled with care since it's a corrosive substance and can cause burns. Therefore, we should use personal protective equipment, making sure that we're wearing our lab coats, putting our goggles or face shield, and wearing gloves. In addition, all reactions should be carried out in a chemical fume hood because of the use of sodium hydroxide. In the first method, we're going to demonstrate the reaction using ethanol as the solvent. We're going to start by measuring about 5 ml of 20% sodium hydroxide solution in a graduated cylinder. Then, we're going to add these into a test tube. Next, we're going to be measuring about 2 ml of ethanol in a graduated cylinder and then adding them to our test tube. This would be followed by 2 to 3 drops of our unknown solution. Finally, using a glass rod, we are going to shake our solution gently. In method 2, we're going to be using acetone as an alternative solvent. We're going to start by measuring about 10 ml of acetone in a graduated cylinder and then adding them into a test tube. We're going to be taking a small amount of our unknown and dissolve it in the acetone put in the test tube. Finally, we're going to add about 2 ml of 10% NaOH, and then using a glass rod, we're going to shake our solution gently. Now for the important part. Let's look out for color changes and analyze them together. If the solution turns pale yellow or has no color, we can say that our unknown is a mononitro compound. However, if the solution turns bluish purple, we can say that our unknown has 2 nitro groups. And finally, if the solution turns blood red color, we can conclude that it has 3 nitro groups. It is important to perform control tests to use them as reference. In this experiment, nitrobenzene and dinitrobenzene serve as positive tests, turning into a pale yellow and a purple bluish color respectively, while ethanol on the other hand serve as a negative test, having no color change. Don't forget to collect the reaction mixtures in a waste container designated for organic or chemical waste. So why do these colors appear? What is the reaction mechanism behind it? In fact, when polynitro compounds react with sodium hydroxide, this nucleophilic hydroxyl will attack the carbon and will break the pi bond. We will obtain a resonance stabilized intermediate, which is known as the Meithenheimer complex. These complexes change how electrons are distributed within the ring, creating stable and colorful products. This effect varies depending on the number of nitro groups, resulting in different colors as we've seen in the experiment.